C1 Coordinate Geometry, Example 10. In this example, we were given 2 points P and Q. For the first part, I need to work out the gradient of PQ. So to work out the gradient, that's the change in y divided by the change in x. Well, I can use this. So for the gradient of PQ, I've got y2 minus y1. So I've got 1 minus 7, all divided by x2 minus x1, so 5 minus 3. So I've got 1 minus 7, which will give me minus 6, and then I've got 2 minuses, which will give me a plus of 5 plus 3, which is 8. And then I can simplify that to minus 3/4. So that's my gradient for PQ. For the second part, I've got to find the equation of a line parallel to PQ, which passes through the point 1, 4. So if a line is parallel to PQ, that means it's going to have the same gradient as PQ. So the gradient is going to be the same as PQ, which is minus 3/4. And then I've been given this point here, so this is going to be my x1 and this is going to be my y1. And now I can plug these values into this formula here. So I've got y minus y1, which is 4, so y minus 4 is equal to m, which is minus 3/4, and then x minus x1, so x minus 1. Then I can multiply by 4 on both sides, so I'm going to get 4y minus 16 is equal to, and then expand the brackets on this side, minus 3x plus 3. I want to get this into the form y equals mx plus c, so I'm going to take everything over to the other side. So I'm going to get y is equal to, so I've got minus 3x, I'm going to divide by 4, so I've got minus 3/4 x. And I've got plus 3, I'm going to take the plus 16 over, so I'm going to minus 16 over, so I'm going to plus 16, so I've got plus 3 plus 16, which is plus 19, and then divide by the 4, so I get plus 19 over 4. So I've got this in the form y equals mx plus c. This is my m, minus 3/4, and this is my c. So my m is my gradient minus 3/4, and I can just check again to see I've done that right, because I should get this gradient minus 3/4. For part 3, I want the equation of a line perpendicular to PQ which passes through this point. So this is going to be my x1 this time, and this is going to be my y1. But I want the equation of a line that's perpendicular to PQ, so the line is going to be at right angles to PQ. So if you remember the previous example, we looked at two lines which were perpendicular to each other, and we discovered that when we multiply the two gradients together of the two perpendicular lines, it equaled minus 1. So the gradient of this perpendicular line, when multiplied by the gradient of PQ, which is minus 3/4, should give us minus 1. So the gradient will be 4/3 of the perpendicular line. Another way to think of it is the reciprocal of this. So I'm going to flip this around. So instead of 3/4, I've got 4/3. And then instead of the minus, this turns into a plus. So now I've got my gradient, I've got my point, so I can put it into this formula again. So I've got y minus y1, so I've got y minus 1 is equal to m, which is 4/3, and then x minus x1, so x minus 2. So if I multiply by 3 on both sides, well actually let's just simplify this first. We've got two minuses, which will give me a plus. So I've got y plus 1 is equal to 4/3 x minus 2. And then I multiply by 3 on both sides, so I get 3y plus 3 is equal to 4. And then I'll multiply that out as well, 4x minus 8. And then I can, to get into the form y equals mx plus c, I'm going to take this plus 3 over. So I've got 3y is equal to 4x, and I've got minus 8 minus 3, so I get minus 11. And then I'm going to divide by 3, so I get 4/3 x minus 11 over 3. So I've got it in the form y equals mx plus c. This is my m and this is my c, so this is my gradient 4/3, and we can just check back to see that's what we started with as a gradient.